Welcome to the video lecture on image segmentation. Myself, Dr. A. Srinivas, Associate Professor, Department of ECE, Pragati Engineering College. So now here we are going to discuss about the image segmentation. Before going to this topic, what is meant by segmentation? So any image we can take that can be constituted divided into constituent parts. So that image can be divided into some sub parts, sub regions here. So that is main intention of the image segmentation is here we are going to divide that image into number of parts over there. And this segmentation process in the image processing mainly used for in the analysis of the images here. Analysis of the images we can go for. So here the main intention of this image segmentation is here we are going to identify the particular object in any of the one of the image we can capture. In that image we are going to take one of the object from the image here. In that cases the image segmentation is mainly used here. Suppose as an example we can take one of the image which can be captured by using a camera, either a satellite image or by using the helicopter. With the help of the helicopter an image is captured. So that is vehicles which are moving on a road. The vehicles which are moving on a road, that image can be captured. And now in that image consists of, that is the along with the image, the buildings over there and the rivers, trees or whatever the things are available there, all the things are appeared in that image. And now we want to identify one of the object, that is a moving vehicle in that particular image. So that is with the help of this is going to be identified. That means a thresholding process or a region splitting and merging. Different kinds of the processes are there. We are going to identify that particular image. And now here the main intention of the image processing here that can be carried out by using this one. So that is image is divided into some sub-regions here. The goal is usually to find the individual objects. Main intention is individual objects. So here in this part of the image segmentation, so two kinds of the approaches are there. Here two kinds of the approaches. We are having two approaches are there. So one is based on the discontinuity. Based on discontinuity, and another one is there here similarity here. Based on the discontinuity and as well as the similarity we are going to take here. So similarity is in the sense that is due to the pixel intensity. Due to the pixel intensity values here we are going to take. Otherwise pixel intensity, color or texture, any one of the aspect we are going to take in the images as the similarity here. And next one is there discontinuity we are taking. So two image segmentation is based on the discontinuity. So there is no continuation in the intensity values or the gray level values here. That is discontinuity is to be appeared in the images here. That is in the gray level values or the intensity. So the discontinuity may be identified, which may be along a line point, otherwise identified with the help of a line and otherwise an edge. So these are the sudden changes in the intensity along the boundary line. Sudden changes in the intensity along the boundary line, that will be called as an edge here. And now the discontinuities are here detected. The discontinuities are detected here by using detection of discontinuities here. Detection of discontinuities. So the detection of the discontinuities of the intensity values based on here, one is the point detection is there, point detection, and another one line detection, and another one is the edge detection here. Line detection, point, and as well as the edge detections are there. So the most common way in this detection of the discontinuities, we are going to use a mask. We are going to use a mask that will be scan the entire image here over the image. That going to scan the over the image. So that mask will determine which type of discontinuity is occurred here. Which type of discontinuity is to be occurred in this category here. So that is the three types of the discontinuities are there, and there is a point, line, and the edge detections are there. So now here we can take one of the example here we are having. So in this, this is the image here. In this image, a particular point here we are having. So this is the one we are going to identify at the particular point. And now in this category, just we can say we are going to use one mask here. This is called one mask. So now the mask here at the center here we can take the 0, 0 identification. And now the values for this column, this is a mask here we can take, and the weights W1, W2, 3, W4, 5, W6, W7, W8, and W9 here. So here these are the weights of the particular mask here we are having. Whenever we are going to scan this mask on this particular image, so here an average value is going to be calculated. An average value is going to be evaluated. So that is R equals to here, R equals to the weight, whatever the value here it is having, that is Z1, Z2, Z3, image values Z4, Z5, Z6, 7, Z6, 7, 8, and 9. So up to these values are over here, and whenever we are going to scan this mask on this image, an average value is going to be calculated. So that is W1 Z1 plus W2 Z2, so and so on up to here W9 is the Z9, the values we are going to get here. And finally the R image here for this image, so I equals to 1 to 9. So that is Wi and the Zi values we are going to get. So this is an average value of that particular image. So with the help of this image is going to be identified very clearly here. And this should be, the maximum value should be, here it should be greater than or equal to some maximum non-threshold value here. It should be greater than or equal to T. T is a non-threshold value here. T is a non-threshold value. So for this here, we are going to use one mask over here. Just we can take this mask. So here, this is one of the masks here we are having with the help of some values. So 1, -1, -1. So that average value here will be 0 for this. And this can be used for identification of the particular any black spot, torn part of a turbine blade. Just as an example here we can take, to identify the torn part of the particular turbine blade here. So that is, this is one image here we are taking. So this is the part of the turbine blade here, and this is the identified. To identify the particular part of the torn part of the turbine blade. So now we are going to place this mask, that is scan this mask on this particular entire image. So wherever the black spot here will be there, that is a torn part, so that will be appeared here in this image here. So that will be here, the rest of the part, only the particular whatever the part here, torn part will be there after scanning the image. after the scanning the mask onto this image, we are going to identify the particular turned part in that image. So this is the point detection. Only we are identifying on the turbine blade one turned part here we are identifying. On a turned part we are identifying here. And now along with this here we need to identify. Suppose here we want to identify a line. This is going to be identified with the help of a point only. And whatever the things here we can take, suppose any points are over there, the points are identified with the help of this point detection. And to come to the point of the lines. So here line detection. The line detection here we can take. So in this line detection we are going to take. Sorry. The line detection here we need to identify. We need to identify the line detection over there. So here different kinds of the lines are there, and whatever here we can take. So whether vertical lines are there, vertical lines we need to identify. Horizontal lines are there, and also the plus diagonals lines are there. So diagonal plus 45 and minus 45 degrees here. Plus or minus 45 degrees here. That are diagonal lines are need to identify. So for this identification of the diagonal lines, we are going to use some specified masks are there. So that specified mask here we can take. So here the horizontal line we are taking here. This is the horizontal line. So the values here we are taking to identify this horizontal line. So -1, -1, -1. So this is the horizontal line for the identification. Horizontal lines identification mask here. And similarly, here we can take the vertical lines here. The vertical lines 2, -1, -1. Here the vertical lines here. Whatever the vertical lines are presented in the image, whatever the vertical lines are available in the image, that are clearly identified with the help of this vertical mask here. And now we can take the plus 45 degrees and the minus 45 degrees here. So we can take this is the one here we are having plus 45 degrees. So 2, 2, 2 and this is -1, -1. So plus 45 degrees. So in this plus 45 degrees, whatever the lines which are available, which are there in the direction of plus 45 degrees, that lines are identified with the help of this mask. We are scanning that mask onto the image here. And now minus 45 degrees here we are taking. So that is a minus 45 degrees here. So in this minus 45 degrees we can take. So these are the mask values here we are having. So it is the mask values are there. So minus 45 degrees here. In this minus 45 degrees, the axis, that is the diagonals which are there in this kind of direction, that are clearly identified. So now just as an example here we can take to identify this particular diagonals are straight, or that is the horizontal or the vertical lines. Just one of the example here we can take. So with the help of the example we can identify very clearly here. We can identify very clearly about the diagonals here. Just as an example here we can take. So this is the one we are taking the example. This is the one example here we are taking. So suppose here this is the example here we are taking, and it is a box here.